Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ont. In this tutorial video, we'll go through this November 2022. This is paper 4 variant 2 for the 0620 Cambridge International IGCSE Chemistry. This is an extended paper typically offered to students who are doing the triple sciences of the higher ability. In this first question, we have diamond and graphite. We know that there are different solid forms of carbon. Typically, this is what we call allotropes. They can have different structures and hence they have different forms there. So these carbon atoms in diamond and graphite, they're arranged in different ways. So we know that in diamond, each carbon is bonded to 4 other carbons, and then it get continuously branch out in this each carbon being bonded to 4 other carbons. So that's essentially diamond framework there. State the term used to describe the structure. So this is the giant covalent structure. So it's a giant covalent structure. In fact, graphite also has the exact same structure. Now name an oxide that has a similar structure. In the syllabus, there is something called silicon 4 oxide. So silicon 4 oxide, because the 4 there, the IV stand for the silicon in the +4 oxidation number. If you learn oxidation number, that is exactly what it means there. But it is not saying it is ionic. It is just saying that, that is what oxidation number is. It assumes it's ionic, even though non-metal and non-metal, they form a covalent bond. In terms of silicon dioxide, each silicon is bonded to 4 other oxygen like this, and then each oxygen is bonded to 2 silicon like this, and then of course the structure get continuously branch out. So each silicon bonded to 4 other oxygen. So that's just part of the giant covalent lattice structure there. So just want to highlight that there are 2 different things. This is diamond, this was silicon 4 oxide there. Now describe the arrangement of atoms. The arrangement of atoms in graphite, as it is an element and therefore it consists of all of the same atoms. So we know that we have a layered structure. So graphite has a layered structure. So meaning to say that within each layers, what do we have? Have a layered structure of hexagons. Hexagons formed by each carbon atom bonded to 3 other carbon atoms, and having only formed 3 covalent bonds. That means that you are not going to have use up all your outer shell electrons. That's why there's 1 free electron on each carbon atom to conduct electricity there. So you have a layer structure, each carbon atom bonded to 3 other carbon atoms, and and then with each layer of atoms held together by the weak van der Waals forces. So there is the weak van der Waals forces in between the layers, but this question is more about between the atoms. So the arrangement of the atoms there is just layer hexagons, and the structure is flat, so it has a flat layered structure. And explaining how graphite conduct electricity. So each carbon only uses 3 out of 4 outer shell electrons for bonding. So they uses only 3 out of 4 outer shell electrons. That's what you call valence electrons. So you can use outer shell electrons. They use these for bonding, and therefore 1 free electron on each carbon to conduct electricity. And this is throughout the giant covalent structure of graphite. Next one, Buckminster Fullerene. Buckminster Fullerene, the relative molecular mass, MR. The fact that you have relative molecular mass, this means you exist as 1 single molecule. The fact that you exist as 1 single molecule, it means that you have a simple covalent structure. That means your melting and boiling point are going to be relatively low compared to something that has giant covalent structure like diamond and graphite and silicon oxide. You only have carbon. That's why they say it's another form of carbon there. So 720 divided by 12. Press that into your calculator and you get 60. So this means the number of carbon atom, there's just going to be 60 there. All forms of carbon burn to produce carbon dioxide, including diamond. Name the substance used to test for carbon dioxide. You use lime water. I think I spelled it incorrectly. So lime water will turn milky, will turn cloudy in the presence of carbon dioxide, because lime water is a saturated solution of calcium hydroxide. Being a saturated solution, it contains the maximum amount of calcium hydroxide ionic solid dissolved in a given volume of solution at a particular temperature. It's a solution. This is a gas. You bubble into it. What you're going to get is this is alkali, or you can call it a base, and then carbon dioxide is acidic oxide. Acid plus base, you're going to get the salt and also water. This is your classic neutralization reaction. Neutralization reaction producing you this salt Ca2 plus CO3 2 minus, and you will get water, and that equation is balanced now. CO2 take away 1 oxygen, CO3 2 minus, and leaving you behind with H2O there. Lime water turn milky, because all the group 2 carbonates are insoluble in water, and that is why your initially soluble solution, lime water, saturated solution of calcium hydroxide, will turn milky and cloudy precipitate will come out. That's it for that first question, and marks that. Question number 2, sodium is a very reactive metal. Why do you store it under oil? This is to prevent exposure, to air, or you can say to the water or to the moisture in air. Therefore, potentially harmful, potentially reactive. So you keep it under oil, and that will prevent it from being exposed to the water or moisture in the air. Part B, sodium burns in air to form this sodium oxide. So what is the reaction called in which a substance burns in oxygen? You actually require oxygen that is present as 21% in dry, clean air. So what happened there? This is what you call combustion. Here is combustion of sodium. What is the color of the flame? So we know that sodium burns with a yellow flame, kind of like orange yellow, but I think it's typically just stated as yellow flame there. Write a chemical equation for the reaction that takes place when sodium burns in air. So a chemical equation there must be balanced no matter what. So what we have is sodium reacting with diatomic molecule of oxygen, being 2,6 electronic configuration. The atom is not going to happy on its own. Therefore, they want to share 2 electrons to fully fill your outer shell, and when they do that, they're gonna form 2 covalent bonds, so 2 electrons from each oxygen, but you only use the outer shell electrons for bonding, so you're left with 4 more in the outer shell of each oxygen. If I draw the display formula, there's a double covalent bond there, giving you these diatomic molecules, 2 atoms being bonded covalently to give you a molecule. In terms of the compound, you're going to get, as you can see the diagram below here, you're going to get Na plus, O2 minus. How in the world do I get that? We know group 1 metals form a +1 cation. We know the group 6 nonmetals will form a 2 minus anion, having gained 2 electrons in the outer shell to complete the outer shell there, because the partner is a metal. Here, the partner is a non-metal with itself, that's why it forms covalent bond by sharing electrons. Looking at the charges of the ions, that is what we call valency. Valency is what you call combining power. How do you combine with each other? And that we crisscross, we do cross multiply of the valency, and we will get how many in the lowest common multiple in the simplest ratio. So 2 on the left means 2 of these Na plus. So I'm going to write down 2 of the Na plus, and 1 on the right means 1 O2 minus, such as what I've just formulated earlier. That's why the correct formula is 2 of the sodium and 1 of the oxygen. The charges cancel out. That's the objective of the game. Ionic compound does not have overall charge. +1 added with -2 get cancelled out to give you 0 overall charge there. Must balance our equations. There is only 1 oxygen, but there is 2 oxygen. So the first thing I do would be to put a 2 in front of Na2O. It means I have Na2O, so that I can see 1 oxygen, 2 oxygen to balance the 2 oxygen. Having done that, I've got 2 sodium, 2 sodium, I got 4 sodium, so I need 4 in front there to balance my equation there. Completing the dot and cross, so we know that sodium started out with 281, so you will have lost your outer shell, then sodium become 28 there. So sodium has been drawn as cross in the first shell, so I'm going to continue that with crosses in the second shell. 2 and 8, this is now a plus, and then draw the same thing for the other one. 2 and 8, you have lost your third shell electrons, now this is also a plus. And in terms of the oxygen will have gained electrons. Oxygen started out with 6 electronic configuration, O2 minus, because you wanted to gain 2 electrons from the metal atom having lost it. So I've used dot for the oxygen in the question. So, I could have completed with 6 original dots, 1, 2, 3, 4, 5, 6 original dots. But I have gained 1 electron from this sodium. I have gained another electron from this sodium. Each sodium atom can only give away 1 electron. I need to get 2, therefore I need 2 sodium atoms giving me that. And overall charge there will be 2 minus, because you have gained 2 extra electrons. Your number of protons is still 8 protons, but now you have 10 electrons, more electrons than your protons, minus 2 overall charge there, having gained 2 extra electrons for that 3 marks overall question there. In C, explain in terms of proton transfer what is meant by a base. In the syllabus, we know that a base accepts H+. And why is it able to accept H+? A base has OH-. OH- can accept H+, because that is the ionic equation to form water. That is your neutralization reaction there. Neutralization between the H+ of acid and the OH- of an alkali or a base to give you water, which is neutral. Now state a pH number that indicates the presence of a strong base, a strong alkali. We're going to go all the way to the very end. So pH 14, pH 13 should be okay as well. Now you have methyl orange. This is an indicator. In your titration, when you put it in sodium hydroxide, which is a base, it's going to go yellow, and then it's orange at the end point. Orange at the end point, and we know that it will be red in acidic conditions. Part 4 is about mole calculations. So these questions have been very generous, asking you to do these in various steps. So we're going to do stepwise kind of thing. We want to do the overall concentration in gram per dm cube. But the first thing we have is the reacting mass. So the idea of reacting mass means that we can use mole of sodium equal to mass of mr. Well, in fact, this is just atom, so we'll just say ar instead of mr. So this is just 0.345 divided by 23, which is the relative atomic mass of sodium from the periodic table. This gives me 0.015. Don't forget your unit, 0.015 mole then. Now, what is the mole of NaOH form? We see that this is NaOH that I've underlined. This is sodium there. So the mole of sodium is to the mole of NaOH is 2:2. Then divide by 2 both sides, because I can get 1:1. This is the simplest mole ratio. Now, if it is 1:1, this means that the mole of NaOH that you form is equal to the mole of Na reacted. So this is also 0.015. It's equivalent, because 2 mole of these give you 2 mole of that. If 0.015 mole of this reacted, you will also get 0.015 mole because of the mole ratio based on the balance equation. Now, based on that, we have the mole of NaOH. Now we are looking at a solution. Solution will have concentration times volume to give me the mole. Concentration there has to be the mole divided by volume. I have the mole, that is the mole, but looking at the unit, this is divided by dm cube, So what do I have at the bottom? I have the volume of solution there, that is 50 cm cube. So we do know that in terms of cm cube going to dm cube, we need to know the conversion. So 1 dm cube is 1000 cm cube. So when you go from cm cube, which was 50 cm cube, to go to dm cube, I need to divide 50.0 divided by 1000. That is now dm cube at the bottom. When you do these mathematics, be careful, use a bracket so that you are not messing up your calculation. 0.015 divided by 50 over 1000, I get 0.3, and the unit will be mole per dm cubed, because that is the mathematics which I had done earlier. Another way of doing this on your calculator is 0.015 divided by 50 times 10 to the minus 3. This is the rule of indices from mathematics, which you have learned in school as well. How in the world do you press times 10 to the minus 3? You press this 50 exp minus 3 button. The exp button is the button usually to the left side of the answer button on the calculator. If you can't do it, you might have to press shift and then exp, depending on what calculator you're using. If you're unsure, just ask your mathematics teacher, yeah? Now determine the MR of NaOH. That's the first part of the question before calculating the concentration in gram per dm cubed. So the MR of NaOH is 23 plus 16 plus 1. So they give me 40. Now in terms of getting the concentration in gram per dm cubed, we can see that mole is equal to mass over MR. So that is your mole equal to mass over MR. So what I'm going to do is I'm going to divide both sides by dm cubed. So mole divided by dm cubed, and then I'm going to get gram divided by dm cubed, because what I do on the left, I'm going to do on the right. Everything else doesn't change. So now you get your last formula. And to get the concentration in gram per dm cubed, that is just going to bring up the gram per mole to the other side. And I'll get mole per dm cubed multiplied by gram per mole. Gram per mole is MR. What is your mass in 1 mole? What is your mass in 1 mole? So this is the mass in 1 mole of the substance. This is how many mole in 1 dm cubed. So that is 0.3 mole per dm cubed multiplied by 40. And I get 12 gram per dm cubed as my final calculated answer there. Part D, so we have this thing called qualitative analysis. These are the tests of ions from your practicals as well as alternative to practical. But in theory paper, the table of results, the table of tests will never be given. Now, where you form a solid from 2 solutions, we know that this is basically what you call a precipitation reaction. Now, this reaction involves the OH minus aqueous from the sodium hydroxide, and you're adding Fe3 plus aqueous, and then you will get the precipitate Fe3 plus OH minus. Looking at the charges of the ions, the valency, which is based on the value of the charge, -1 give you 1, +3 give you 3. We exchange the valency, so 1 goes to the left, 3 goes to the right. This is labeled as how many. Well, you need 1 of the Fe3 plus, because it says 1 of these, 3 of these OH minus. So I'm going to write down 3 OH minus. The most confusing thing that a lot of students did was they write things like FeOH3. This is totally wrong, because what you have written down is only 1 oxygen. There is 3 oxygen. So you're going to do with bracket, the whole thing in bracket. There are 3 lots of it. There are 3 lots of the thing in the bracket. -1, -1, -1 give you -3. Cancel out +3. Ionic compound has no charge there. This is a precipitation reaction. As I'm going to move on to the last bit first, to be honest. In terms of the writing the ionic equation, that's going to give you the FeOH 3 times and solid. So stating the state symbol is very important. This is precipitation. I also need to balance the equations. I have 3 of the hydroxide coming together with 1 of the Fe3 plus, giving me iron 3 hydroxide. This name of the product is called iron 3 because, as stated in the syllabus, you need to know how to use Roman numeral to give the name of a compound containing transition metal. This is a hydroxide. Almost all metal hydroxide are insoluble except for sodium hydroxide, potassium hydroxide, and some other things like ammonium hydroxide, which is ammonia, as well as other group 1 hydroxide. State the color. This is your observation part of the practical. Iron 3 hydroxide is going to be red-brown precipitate. And when you add in excess, it is insoluble. In excess, sodium hydroxide aqueous. If you do this with aqueous ammonia, it's going to give you the same result, red-brown precipitate, insoluble in excess, aqueous ammonia as well. That's it overall for this 22 marks question there. This question number 3, we have sulfuric acid manufacture. This is part of a process called contact process. So name a metal ore. So you need to name a metal ore. So this is zinc sulfide. So zinc sulfide there is actually what you call, I forgot what it's called already. I think it's blende, B-L-E-N-D-E. Second part, describing the process which converts these metal ores to sulfur dioxide. So example, we will have started from zinc sulfide. So that is basically blende, that's the mineral. And then you react that with oxygen, you roast it in oxygen. So the zinc is gonna form the zinc oxide, and then the sulfur is gonna form the sulfur dioxide like that. So let's think about what we're gonna form here. We're gonna balance the equations, of course. We're gonna balance the equation as usual. So what does this give us? This gives us 3 oxygen atoms on the right hand side. So there's 3/2, because 3/2 multiplied by 2 giving you 3 oxygen atoms from the oxygen molecules. If you really don't like this, you can multiply the whole thing by 2. That this become that, and you get 2 ZNO plus 2 SO2. I mean, both equations are mathematically correct. And also, in terms of chemistry, all the chemical formulas are correct and they are balanced. So, you can't say that they are wrong chemistry. So this process of converting metal ores to sulfur dioxide, so both the zinc and the sulfur actually gains the oxygen. But when you have zinc and sulfide there, so the zinc is Zn2 plus, the sulfur is S2 minus. So the S minus 2 oxidation number, the S plus 4 oxidation number in SO2, as that is a compound. A compound has 0 oxidation number, so 0 there. Sulfur plus 2 times minus 2, because each oxygen in a compound is going to be minus 2 oxidation number. The sulfur is going to be plus 4 in SO2. Minus 2 going to sulfur plus 4. This is oxidation number increasing. That is what you call oxidation there. So describing the process. So I could write the equation, I guess, because they said describe the process, not state the process. So I could say the ZnS plus 3O2 give me 2 ZnO plus 2 SO2. So the zinc and sulfur gains oxygen. But in reality, it's not just about gaining oxygen, because it's also to do with the oxidation number. Because if you think about it, if just the sulfur gaining oxygen, but the zinc is also gaining oxygen, so that doesn't quite make sense. So there is a redox reaction. And describing the process, this redox reaction essentially converts the zinc sulfide, the ore, into the sulfur dioxide, which is essentially what you need for this next step if you are getting the sulfur dioxide from the mineral ore there. Now, naming the industrial process, we did that earlier. That is simply called contact process. Just like the equivalent Haber process is used to manufacture ammonia, contact process is used to manufacture sulfuric acid there. Of course, you know that there is a equilibrium step, and that is the step that gives you the sulfur trioxide here. SO2 giving you SO3. Stating the temperature, that's 450 degrees Celsius. I believe in the syllabus it mentioned is between 400 to 500 degrees Celsius. And the thing that about the contact process is the pressure is not as high as Haber process. This is around 1 to 2 atm, so usually we just use 2 atm pressure there. Naming the catalyst, we know it's V2O5. So the whole compound has 0 oxidation number. There is 2 vanadium and there is 5 oxygen. Each oxygen has a minus 2 oxidation number. 2 vanadium is plus 10. Vanadium is plus 5. This is what they call vanadium 5 oxide. Use Roman numeral to represent the oxidation number of the transition metal when they form compound. Describing 2 features of equilibrium. This is basically the definition of dynamic equilibrium. So we know that the rates of forward and also backward reaction are equal. And then the second bit is about the concentration. The first bit is about rates being equal for the forward and backward reactions. The second one is about the concentrations. So the concentrations of reactants and also products are not changing at all. So reactants and products are not changing. They are constant. They do not have to be equal, but they cannot change. All right, so they do not have to be equal, unlike the rate, but they are constant for the concentration there. The next bit, state the effect as well as explaining your answers. The effect of temperature increasing. So temperature explanation is based on the enthalpy change. We are not told about the enthalpy change, but this is a case study where the forward reaction is actually exothermic. So probably something that you need to know in order to be able to do this question, because it's not provided, right? So it's a case study. The forward reaction is exothermic. The forward reaction releases heat energy to the surrounding. There's a definition of exothermic reaction. When temperature increases, the equilibrium, which is the system, or you can say the equilibrium, will try to decrease the temperature. How do you decrease the temperature? So try to decrease the temperature. So how would you do this? You only know how to release heat energy. So how do you decrease the temperature on the outside? You want to make the outside cooler, so I'm going to release lesser heat. And when I release lesser heat, what happened to the position of equilibrium? So therefore, shift to the right hand side, because shift to the left hand side, because forward reaction release heat. So going from left to right release heat, and when I want to release lesser heat, I want to shift to the left side. I want to favor the backward equilibrium. In terms of pressure, we need to count the mole of gases. So there is a gas, there are 2 mole plus 1 mole. There's 3 moles of gas on the left, 2 moles of gas on the right. So we state that exactly, 3 moles of gases on the left, and then we have 2 moles of gases on the right. And then we can imagine that, the greater the molecules of gases, therefore the greater is the pressure. So what happens when pressure increases? Well, when you increase your pressure, what will the equilibrium tries to do? The equilibrium, which is the system, it will try to do the opposite, which is to decrease the pressure. How do you decrease pressure? Of course, you will shift to the side with lesser gaseous molecule, because the lesser your gaseous molecule, the lower is the pressure. So lesser gases, based on our first statement, they will be on the right side. So therefore, equilibrium will shift to the right hand side, favoring forward reaction, and your yield of product will increase. But this question is on position of equilibrium, not on the equilibrium yield there. So be very careful. Next bit, explaining in terms of particles, what happened to the rate of reaction. So this is about kinetic particle theory as well as collision theory. So we know that when temperature increases, this will affect your kinetic energy. So your reacting particles will have gain more kinetic energy. And when the reacting particles gain more kinetic energy, they will move faster. Their speed is higher, so they move faster. And as a result of this faster motion, faster movement, they collide more frequently. So now I'm relating it to collision theory. This is to do with collision frequency. Colliding more frequently, therefore more successful collision. So successful collision there refers to collision that have enough energy to overcome your activation energy, or sometimes people call it more effective collisions. As a result of this, therefore, overall rate of reaction increases if you have more particles that have enough energy to overcome the activation energy. Your rate of reaction will have increased there. Last but not least, we have this reaction with ammonia, which is acting as a base. And when the base react with the acid, you will get neutralization reaction. The key thing about ammonia reacting as a base is, instead of just getting salt and water, you're just going to get salt, because of the way the formula of ammonia is designed is such that you don't have the hydroxide seen in the formula. But of course, we know ammonia dissociate in water partially to give you OH minus. So aqueous ammonia does have OH minus there. And if you say this is a gas, well, there is water in the acid, so water in contact with ammonia will have given you the OH minus ion for neutralization as well. So this salt has a name, it's called ammonium. Just now your base was ammonia. Ammonium is a cation. The salt is sulfate. Sulfate is SO42 minus, ammonium is NH4 plus. We think about the valency, and then we're going to exchange the valency as that is your lowest common multiple in order to cancel out the charges. That means how many of these ions you have. I'm going to have 2 of that NH4 plus. I'm going to have 1 of these SO42 minus. My chemical formulation that is correct will be using bracket 2 of these NH4. So 2 of whole thing in the bracket, 2 of them, and 1 of this sulfate. So I don't need a bracket for that. Having gotten the correct formula, ammonium sulfate, the salt is when the H plus of acid get replaced by cations. So there's the ammonium ions stated in your syllabus as part of test for ions. Got to balance the equation. 2 of that give you 2 of the ammonium. 2 times 3 is 6 hydrogen plus 2 hydrogens. 4 times 2 is 8 hydrogens, and that's how you balance the equation there. Name the compound. They do not want the formula, so I was just showing you the formula because I can't, and because you never know when they ask you to write down the formula. Correct? That's it really for this 16 marks overall question there. In this question number 4, so we wanted to prepare these magnesium sulfate crystals. So this is from crystallization. So if we have crystallization, we are looking at soluble salt. You do know that sulfates are soluble except for barium sulfate, white precipitate, calcium sulfate, white precipitate, lead-2 sulfate, white precipitate. They are typically prepared by this method called precipitation. So we are not using precipitation here. We are using the metal, using excess of the metal. Because metal is solid, we can filter off solid that are in excess easily. And this is reaction with dilute sulfuric acid. Writing a chemical equation must be balanced. So this is just magnesium metal reacting with sulfuric acid, H2SO4. You're going to get a salt. The salt is what you get when the H plus of acid get replaced by the cation. This is metal. Metal is not cation. Metal is an element. It has no charge. Then when it forms salt, the cations of the group 2 metal has a +2 charge, having lost 2 outer shell electrons, SO42 minus. When you see the charges of cation and anion are the same, you're going to have 1 of each, so that +2 cancel out -2. Magnesium sulfate is just 1:1 in the chemical formula. You also release hydrogen gas. This is one way of producing hydrogen gas in the school laboratory from the acid plus the metal. Describe 2 observations, but be very careful. Reaction has finished. Reaction has finished. This goes back to this idea of excess. You use excess metal, but we know reaction has finished when there is no more bubbling because no more hydrogen get given off. So no more effervescence, no more bubbles. So that means no more gas. No more effervescence, no more bubbles. Therefore, no more hydrogen gas get produced. Or what can we say? Describe the observation which show the reaction is finished. Another thing I can think about is the magnesium. So no more solid. No more, hang on, the solid will remain, okay? So no more change in the amount of solid. So no further change. No further change in the amount of solid remaining because the solid will just stay stationary because it doesn't react anymore. So magnesium in excess, therefore not all of it reacted. Not all reacted there. Hence, you should be able to, remove this excess magnesium, which is the metal, unreacted metal. What is given to this solid separated from a solution? So this is the insoluble magnesium metal collected on the filter paper. So this is the solid that get left behind the filter paper. That's called residue. So when you have a filter funnel, and the filter funnel will have a filter paper on top, then these are your residue that is left behind on the filter paper, and you will have a liquid that pass through. That is what you call a filtrate there. Part D, so we have this filtrate, which is basically the solution that passed through. It's heated until crystals begin to appear. Actually, this is until saturated solution. We do actually have to allow the solution to cool down. Only then crystals will appear. Normal solute can dissolve at a particular temperature. This is called a saturated solution. Heat until the solution is saturated. Why more crystals appear on cooling? Because solubility changes. Solubility decreases with temperature. So that means that at a higher temperature, more of it will dissolve. So more crystals will form. Upon cooling, more crystals crash out, or they will form upon cooling because they are insoluble, since you can only fit a certain amount of solute at a particular temperature. The ideal temperature affecting solubility is a very common thing in practical as well as alternative to practicals there. In the next part, we have this formula. This is called hydrated. So the whole thing is called hydrated compound, hydrated magnesium sulfate there. But this is saying that name the term given to crystals containing molecules of water. So the term is going to be called hydrated, whereas this .xH2O, that is your water of crystallization. So there are two different terms there. If you have water of crystallization, it means you are hydrated. But when you don't have water of crystallization, this is what you call anhydrous. So this is an anhydrous magnesium sulfate, whereas hydrated magnesium sulfate is the one with the water crystallization. Remove the water crystallization by strong heating and you will get this anhydrous compound there. So this is a follow-up of the calculation we did previously, I think. Nope, we haven't done any calculation yet. So this student heated up a sample of this magnesium sulfate, hydrated. So we found out that it has lost this much mole. Be careful, this is mole. And you have this much mass. So this is mass. So what we're supposed to do, use the following steps, calculate the MR. So whether they give you step by step or not, you should be able to, convert this gram into mole with the relationship of MR. So there is 24 for the atomic mass of magnesium, plus 32, plus 16 times 4. On the calculator, 24 plus 32, plus 16 times 4, I get 120. There's the MR. So calculate the mole of the magnesium sulfate. So we label our work so that we ourselves are not easily confused. There's your mass in gram. That is your gram per mole at the bottom. As that is what you call molar mass. MR 2.4 divided by 120. I get 0.02. Again, writing down the unit will help you to label your work. Last but not least, calculate the value of X. We see that in this formula unit, we have 1 mole of magnesium sulfate has X mole of H2O. So if I say mole of H2O divided by the mole of MgSO4, so hopefully you can see there's X mole of H2O is to 1 mole of MgSO4. So X divided by 1 is X. And then I'm going to put in the actual value on the right hand side. We have the actual mole of MgSO4 that we have left after we remove all the water crystallization. We had this much, we have lost this much mole of water, 0.140. So 0.140 mole of water. Having lost that, and you're left with this much mass of MgSO4, which I found the mole by relationship with mass of MR. So there's 0.02 at the bottom there. X divided by 1 is X. So 0.140 divided by 0.02, this gives me 7, which is a nice whole number. Now you might not like the use of fractions. You could use the idea of ratio. MgSO4 is to H2O is 1 is to X. And then we have our 0.02 mole of MgSO4. There's our actual mole there. So I'm going to put in my actual mole, 0.02. We have lost 0.140 mole of water. 0.140 mole of water. So what you could do is you got to make this into 1 and then this will become X. So to make this into 1, I have to divide by the simplest ratio, the smallest number, I guess. And what do I get? 0.02 is the smallest. So 0.02 divided by 0.02 is to 1.40. 40 divided by 0.02. This gives me 1:7. So therefore x equal to 7. So that is an alternative way to do what I just did there, to find the value of the water crystallization there. So there's always more than one way to actually do this kind of mole calculations, rather than just, having said, there's only one method. There's actually more than one way to think about the problem there. Last bit of this question, this is about the decomposition of this magnesium nitrate. So Mg2 plus, then you have NO3 minus. We think about the chemical formulation. It's all about the lowest common multiple of the charges. Your objective is to cancel out the charges. So the valency is the combining power based on the charges of the ions. We look at the value of the charge there. So there's the combining power. We do crisscross, exchanging the valency. And this level is called how many. So how many of these Mg2 plus? Well, one of these Mg2 plus on the left and two of these NO3 minus on the right. You could see that the charges cancel out, and the objective really is about cancelling out the charges. And how many of these nitrate you have? You have two of them, so we use bracket there, magnesium nitrate. This question is more about the decomposition of group 2 nitrate. You will get a group 2 oxide. When you could see Mg2 plus and O2 minus, the charges cancel each other out, so they are equal and opposite charge. So that's why you have one of each in the simplest whole number ratio. You also get NO2 gas, and you also get this colorless gas which you cannot see, but you can test for it with a glowing split and you will get it relighted in the presence of oxygen, of course. Got to balance the equation. We have two of these nitrate. We're going to get two of these NO2. Now everything else is balanced, one magnesium and one magnesium. NO3 will give you the 2 NO2 because you've got 2 NO3 there. 6 oxygen, 3 times 2. I can imagine 3 plus 3 is 6 oxygen. 2 times 2 is 4 oxygen. Plus 1 is 5 oxygen. I just need 1 oxygen there. I cannot change the identity of the oxygen molecule. What I could do is I could put a half in front. A half multiplied by 2 give me 1 oxygen atom from this half of oxygen molecule. Say you really don't like the half. You can multiply the whole thing by 2. You're going to get 2 Mg NO3 twice. So everything get multiplied by 2. That means the left and the right hand side. And the half multiplied by 2 will just give you 1 mole of O2. Should be able to balance the equation the exact same way. Both of them are exactly the same. It's just mathematics. It's just ratio. So whether you write this with a half or whether you write this with a whole number 1 there, both of them are equally balanced and correct there. Didn't ask for stat symbol, so I don't have to. That's the end of that 12 marks overall question there. This question number 5, this is organic chemistry. So ethane is an alkane. We know alkane only contains carbon-carbon single bond, and it is a saturated hydrocarbon. It contains hydrogen and carbon atoms only. And saturated basically means only carbon-carbon single bond. Alkane has a general formula of CnH2n plus 2. You could see that 2 times 2 is 4 plus 2 is 6. So this is ethane, where there's 2 carbon alkane there. Why this reaction is described as a photochemical. So the photo there is initiated by light. So the chemical there, of course, is referring to a chemical change. There is a change in your composition of your identity. So this reaction requires sunlight. This reaction needs sunlight or requires sunlight. Or we can say UV light, which is ultraviolet light, to start or to initiate the reaction there. Part C, 1 atom of hydrogen is replaced with a chlorine atom. An atom replaced with a atom. So be careful. So there is 1 atom of hydrogen replaced with 1 chlorine atom. So replacing, the word replacing for this type of organic reaction, what is the name? This is called a substitution reaction. Alkane doesn't undergo addition. Alkenes undergo addition because alkenes have carbon-carbon double bond. When you only have carbon-carbon single bond, you cannot do addition. Alkanes can undergo 2 types of reaction, one of which is going to be combustion, where you burn completely to give you CO2 and H2O. You can also do substitution chemistry, where you replace 1 atom or 1 group with another there. In this reaction, one of the products is called chloroethane. So you have done CH3, I think, CH3, because there's C2H6 there. So you've done CH3, C2H6 plus Cl2, and you get CH3CH2Cl, because you replace one of the hydrogens with a chlorine, and then you will kick out HCl. There is no water involved in this reaction. There is no water involved. Therefore, you can never get hydrochloric acid. Name the other product, that is your HCl, but this is HCl as a gas. It's not hydrochloric acid because there is no water. This is stated in the Year 9 bonding topic as part of the vocabulary, hydrogen chloride there. So in this part E, we have this energy profile diagram showing us the energy of the reactants. So these are the reactants going from left to right hand side. This is the progress of reaction, going from the reactant to the products, and that is why direction really matters. Going from the energy level of the reactant to the energy level of product, it has decreased because the system loses energy to the surrounding. That's why this is coming down. That is your enthalpy change. It's coming down, it's negative. That is what you call an exothermic reaction. Whereas this is how much barrier of an energy you have to overcome. The reacting particles of the reactants have to overcome this much energy from the starting energy level of the reactants to the top of the peak. That is what you call the activation energy, minimum amount of energy that the reacting particles must overcome in order for them to react. So give the name for the enthalpy change, well, energy change level A. A is what you call the activation energy. If you put down EA, it is not generally accepted because this is the abbreviated form. They want you to give the name of the energy change. The name of the energy change B, that is your enthalpy change. I know we usually label this as delta H. Again, they wanted the name and not the abbreviated form delta H there. So state how this energy profile diagram, so it's from this diagram, shows that this is exothermic reaction. So I mean, we know the exothermic reaction result in an increase in temperature of the surroundings, but there is nothing in this diagram that shows us temperature because it's not that kind of what happened to the surrounding, what happened to the solution, what happened to the temperature of the solution. There is nothing in this graph that shows that. What this graph shows is energy level of reactants and products. So going from reactant to products, we could see that the energy of the products are at lower energy levels compared to the reactants, or somewhere along that line you can say that will make it exothermic. So it's lower than the energy of the reactants, or you can mention that the reactants must have lost energy. The reactant must have lost energy when they form the product. That's why the energy of product is lower there, because they release the energy to the surroundings there. Now in this part F, we are given some of these bond energies. So use the bond energies in the table to calculate this energy change, this enthalpy change. So use the following steps. First of all, energy needed to break bonds. So we have to kind of break everything in here. So when we break everything in here, so what are we going to do? So we are breaking 1, 2, 3, 4, 5, 6. We are breaking 6 times CH. So this will be the same as CH from the table. So 410 multiplied by 6. And then we are breaking 1 times CC single bond, as there is the CC single bond and also ClCl single bond. So there's 350 multiplied by 1. And the ClCl and 1 of that. And that is just 240 multiplied by 1. So we're going to add them up later on. Now what else do we form? So that is what we break. And what we are going to form will be everything on the right hand side. So we could see that we're reforming the CC, to be honest. So 1 times CC, and that is just 350 multiplied by 1. And we have 1, 2, 3, 4, 5 of the CH. So 5 of the CH, there's 410 multiplied by 5. What else do we have? We have a CCl and a HCl. So 1 times CCl, so that's 340 multiplied by 1, and 1 times HCl, that is just 430 multiplied by 1. So looking at the value that we have, so I'm just going to cut this here. This is all the bonds that we break. So if I just jumble them up together, I'm going to add this value together. So 410 times 6, 410 times 410 times 6 plus 350 times 1 plus 240. I get 3050 kilojoule. And this is absorbed in order to break bond because bond breaking is endothermic. In terms of the energy release when I form bond, so it looks like I'm forming a lot more bonds, so might not have enough space there. Think might have to squeeze in a little bit there. And when I add this up, I'm going to get 350 times 1 plus 410 times 5 plus 340 times 1 plus 430 times 1, and I get a total of 3170 kilojoule there. In terms of the energy change there is actually enthalpy change. As you could see there, there's kilojoule per mole, which means we must have a sign, we must have a value, as that's referring to enthalpy change now, and the unit is already given. This is the total energy for bond breaking minus the total energy for bond forming. So it's basically the energy absorbed for breaking bonds minus the total energy released for making bonds. And we've already gotten, both of these values previously. So it's 3050, and you take away your 3170. So pressing your calculator, 3050 minus 3170, I get minus 120 signed value as well as unit there. I put a mole minus 1, but I think in IGCSE as well as all level standard, it's quite common to actually just write kilojoule per mole there. That's it for that 3 marks, and that's it for that overall 10 marks question there. Question 6, this is a carboxylic acid. Carboxylic acid has COOH, or you call it RCO2H. You can also call it RCOOH like this. So what they have shown you was something called display formula. In the display formula, show all the atoms as well as all the bonds, including the OH, single covalent bond. What is the general formula of a carboxylic acid? A carboxylic acid must always have COOH, and then this thing in front is what you call the alkyl group. Just like in alcohol, there will be like CnH2n plus 1, because you take out one of the hydrogen of alkane. Alkane was CnH2n plus 2, take out one hydrogen, replace it with OH for alcohol, replace it with COOH for carboxylic acid, such that we get CnH2n plus 1, COOH. Be very careful. This is already one carbon. If you already have one carbon, so that means this is n equal to 0 because you already have one carbon in the CO2H. So that means 0 carbon there because you already have one carbon there. 2 times 0 is 0 plus 1, that gives you one hydrogen. That is why we have one hydrogen in front in this thing called methanoic acid. It's a one carbon carboxylic acid. It's methanoic acid because it's one carbon and you wanted the name there. Write down the molecular formula. This is a year 9 definition. In chemical formula, when you did empirical formula, you also learn molecular formula. It's the actual number of atoms in one single molecule. There is one carbon, there is 2 hydrogens, and then there is 2 oxygen. This is called structural formula because you could see the structure being carboxylic acid there, CO2H. Molecular formula is not structural formula. By writing this molecular formula there, you are saying that you do not know what is molecular formula. Molecular formula is not structural formula. You don't see the structure, you just write the actual number of atoms present, summarized like that. Now complete the dot and cross to show the arrangement of electrons. For 3 marks, you got to think about this diagram. Part of it has been drawn for you. This is the inner shell. We do not use the inner shell for bonding. So carbon has 4 outer shell electrons. They will form 4 covalent bonds by sharing 4 electrons. Oxygen has 6 outer shell electrons. They will form 2 covalent bonds by sharing 2 electrons to complete the outer shell. Hydrogen has only 1 electron in the outer shell, but the first shell can only accommodate 2 electrons maximum there. So if we look at this diagram here, we have got carbon hydrogen single, carbon oxygen double, and that is the double bond there. So what I'm saying is I will have 2 dots from the carbon and I'll have 2 cross from the oxygen. And when the carbon give 2 dots, the oxygen give 2 cross. These are shared, and oxygen started with 6 electrons in the outer shell. We have used 2 out of 6 for covalent bonding. You must be left with 4 more on this oxygen. This is a double covalent bond. 4 electrons being shared give you the double covalent bond. And on the right hand side, you have a single covalent bond. There's 2 electrons, one from this carbon and one from the other oxygen. So here I can draw 1 dot and 1 cross because this is a single covalent bond consisting of 2 electrons being shared in total. And I have gotten cross for oxygen. So I will have cross oxygen. If I use triangle for hydrogen, then you can see that I'm left with 4 more crosses on the oxygen because I use only 2 out of 6, 1 cross, 2 cross. I still have 4 more in the outer shell, and these hydrogens being the triangle there is just going to form a single covalent bond to the oxygen. That's the OH covalent bond. Also a single covalent bond between hydrogen and carbon. So 1 triangle on the hydrogen and then 1 dot from the carbon. You can see that this carbon, 2 electrons in the first shell, 4 electrons, 1, 2, 3, and 4 dot there. And that is fully done there. So that is basically carbon, oxygen double bond, and hydrogen single bond to the carbon, single bond carbon to oxygen, and then single bond to hydrogen like this. This is what you call display formula, where you show the lines representing covalent bonds, and they wanted the dot and cross. This is the way to do dot and cross. Make sure you count your outer shell electrons correctly. Part E, carboxylic acid will react with alcohol. This is propane 1-ol. So draw the structure of ester Z. We know that ester consists of C double bond O, and then you also have the O on the other side because this is the new bond that you have formed in an ester. If I imagine breaking that is the alcohol because you don't have any C double bond O on that side. The alcohol has lost the H. So that means the rest of it is just CH2, and then CH3 because I started with propane 1-ol. Propane 1-ol consists of the alcohol on the other end. So this is carbon number 1, 2, and 3, propane 1-ol. And then on the other side, what do I have? I have carboxylic acid Y. That was just 1 carbon carboxylic acid. That was just methanoic acid. They will have lost the OH from the acid when it formed ester. So just 1 carbon remaining on that carboxylic acid there. So this is just the H. This one has got the C double bond O. So this is of the carboxylic acid. That will have lost the OH when you form ester. So this is the ester. Show all the atoms and all the bonds. We just did that. Show the name. I'll state the name. You got to name the alcohol first. The alcohol was propanol, propane 1-ol. So that is propyl, P-R-O-P-Y-L. And then we have methanoate. Methanoate comes from the methanoic acid, giving you methanoate there. And that's it really for that 3 marks overall question. So the acid has lost the OH, so lost the OH. We're not talking about ions here because we are not talking about acid-base reaction. This reaction is called condensation. When you form ester, you call it condensation reaction. When you form many ester, you call it condensation polymerization. So this OH and the H, they come together, they give you water. So name the other product. The other product is just water. Now name an ester, which is a structural isomer of ester Z. Ester Z contains 1, 2, 3, 4 because 1 carbon acid plus 3 carbon alcohol, 1 plus 3 give you 4 carbon ester. So if I want 4 carbon ester, I have 1 plus 3 earlier, which was 1 carbon acid, and I have 3 carbon alcohol. So that one is done already. So what else could there be? There could be 2 plus 2, or there could be 3 plus 1. What I mean is 3 carbon acid and 1 carbon alcohol. So they say name an ester. They don't say the ester because there is more than one option. If I have 2 and 2, 2 carbon alcohol is ethyl, 2 carbon carboxylic acid is ethanoic acid, so I get ethyl ethanoate. Of course, I could also get, from 1 carbon alcohol, they will give me methyl from methanol, and then 3 carbon carboxylic acid, propanoic acid will give me propanoate. So instead of propyl methanoate, I can get methyl propanoate as the ester, or I could get 2 plus 2, which is ethyl ethanoate. Last but not least, we're looking at a carboxylic acid. Now, carboxylic acid, structural isomer ester Z. Ester Z has 4 carbon total. So what we're looking at is 4 carbon carboxylic acid. Earlier in this question, we were asked for the general formula of carboxylic acid. If you recall, it was CnH2n plus 1 COOH, where this is 1 carbon inclusive. So I'm going to put in the general formula, CnH2n plus 1 COOH. So what I have is, I have a COOH, so therefore n equal to 3, because I already have 1 carbon at the end here. So I'm left with C3H. 2 times 3 is 6 plus 1 is 7. So C3H7 COOH. This is 4 carbon acid. They asked for the name. They didn't ask for the formula. This is going to be 4 carbon carboxylic acid. The name is going to be called butanoic acid. They don't want the formula. They wanted the name of 4 carbon carboxylic acid. Structural isomer. Structural isomers, they have the same molecular formula. So that means they're going to have C4H, and then this is 6, 7, and 8. C4H8O2. Same molecular formula, but different structural formula. That's why these are structural isomers. That's it really for this overall 12-mark question. And that's it really overall for this paper 4 variant 2 for this Cambridge International IGCSE Extended Chemistry for the November-October 2022 exam series. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. Don't forget to share to your friends, chat groups, juniors, seniors, relatives about the resources available on my channel. And thank you for your continuous support. See you in the next tutorial video.